The other thing we're going to do today is also we are going to review, all right, your radical. All right, again, some of you guys will be taking some standardized tests recently. And how was that? Pretty good?
It was actually, I'm taking mine on Saturday. No, I'm taking mine on Saturday.
Okay. So listen to me. I'm just saying.
You gotta take the
Hold up. Guys, it's like I said, I'm trying to get done. I shouldn't have mentioned anything about it. All right, but again, those private school entrance exams are not really that hard. All right, there's just a lot of problems. I do think that reviewing the square roots is kind of important, but again, we also have to start out with the fact that we are discussing right triangles, so everybody should be able to say a squared plus b squared equals c squared. All right, that's the most important thing. So a squared plus b squared equals c squared. Now, a and b, remember, are interchangeable. They are simply called the legs. The c is not interchangeable. The c value refers to the hypotenuse. All right, so in this case, all right, we would just be saying 5 squared plus x squared equals 13 squared. All right, and then we're going x squared is equal to 13 squared minus 5 squared, which I'm sure everybody knows is 144. And so x is equal to what? X is equal to 12. Now, before we go any further, I do want you guys to write something on the top of your page because it will save yourself a bunch of time. It will save yourself a bunch of time. And if you can recognize, all right, if you can recognize what's referred to as the Pythagorean triples, all right, and the triples are just common integer values or whole numbers for these triangles. All right, so what I want you to do is I want you to make sure you write down this. I want you to write down 3, 4, 5. All right, that is a Pythagorean triple. You see that a lot. Now, right below 3, 4, 5, I want you to write 6, 8, 10. Now, how did I know that was a triple? Yeah, I just multiplied it by 2. So any product that I multiply 3 times 4 times 5 by will result in a triple as well. All right, so I could say, for example, 30, 40, 50. All right, is everybody with me on that? So that's the first triple. The next common triple is 5, 12, 13. All right, that is a common triple. All right. Now, again, right off the bat, if you'll notice, you'll see that in question number what? Number 1. All right. Now, I want to take a look at the next one. 5, 12, 13. We would say 8, 15, 17. I need you to write that down. 8, 15, and 17. And then, of course, the next one, the last one that's common, is 7, 24, 25. You can save yourself a lot of time on standardized tests if you know that. Now, I'm also going to show you something super important that I want you to include, all right, that will help you, all right? So again, please write those down. Try to commit those to memory, all right? As we're going through these, we're going to try to find the triples to save us time so we don't have to do the problem, all right? Now, if I'm looking at question number 1, does everybody see number 1? I really wouldn't have to do the problem because I can recognize that that has to be a what? 5, 12, 13. That is a triple. All right? So if we would have done that first, we could easily see. All right, now the next important thing here, guys, I want everybody's attention on this too. All right, we're going to be doing a little bit differently. We're not going to do 8 squared plus 12 squared equals x squared. What we're going to do is I want everybody to make a special note to yourself because you can dazzle your math teacher next year if you learn to manipulate the numbers. All right, 8 and 12 have a common what? 4. So this is 4 times 2, and this is 4 times 3. I already knew the answer was 4 radical 13 without doing any work. You should just be able to look at that and say, obviously the hypotenuse is 4 radical 13. Now, I'm going to reference that. Now, please look up and listen, because I'm going to show you how I knew it's 4 radical 13. All right, please look up. Did you see what I did? I gave a specific reason why I just multiplied the 3, 4, 5 by what? 2. So if I said, for example, 6, 12, the other one would have to be what? 9, 12. Sorry. Can't multiply 3 times 3. 9, 12, then it would be what? Then it would be 15. Because all I did was I multiplied the 3, 4, 5 by 3. Do we agree? So now, what am I trying to show you? Please look up, because I'm really trying to save you a whole bunch of time. All right? 4, question number 2. This was 4 times 2, 4 times 3. So this has to be 4 times whatever 2 squared plus 3 squared is. All right? So that would be 4 plus 9, which is what? 13. So it would be 4 radical 13. Now, because I don't think that made too much sense, I'm now going to show it to you in slow motion. All right, so please look up. In slow motion, this would be this. 8 squared plus 12 squared equals x squared. 64 plus 144 equals x squared. So 144 plus 64 is 208 is equal to x squared. Now when I take the square root of x squared, I have to break down 208. Well, 208 is 16 times 13. All right? And so then 4 radical 13. Does everybody see that? Does everybody agree with me? All right, so now I'm going to try to say it one more time just to make sure that you hear me. Whenever the legs have a common factor, does everybody agree there was a common 4 here, right? That just can come over to the hypotenuse as whatever the answer is times 4. Now, what am I referring to? I'm referring to whatever the answer is to what? 2 and 3. So you're just having to do the Pythagorean theorem with 2 and 3. Now, why is that so much easier? Because I can square 2 in my head, and I can square 3 in my head, and I can add that together, and then I can take the square root. All right, that's what I'm trying to get you to see right now. All right, so try to keep up with me now and work on the mental math. Try to work on your mental math. All right, that's the key. All right, so now I'm on number 3. So on number 3, what is common? 4. So I want everybody to make it super easy on yourself. This is just 4 times 1. And this is going to be 4 times 4. So, no. 4 radical 15. So now look, guys, I'm very happy with that. Those of you guys who are in the game. Even if you said 17, I know you have an idea. You just didn't see that it was the hypotenuse. So I want everybody to make sure you're understanding what I'm saying. Because that is super simple. All right? You need to be better with numbers, some of you. Or it's not that hard. I don't feel like doing 16 squared minus 4 squared and then figuring out what perfect square fits in there. I don't feel like doing that. So I'm trying to show you, recognize these. There's a common 4 here and a common 4 here, right? So up here, it's got to be 4 times something. It's just 4 times however you solve the Pythagorean theorem. Now, you have to remember, I'm only using 1 and 4 now. Now, I'm given the hypotenuse. So if you're given the hypotenuse, you subtract them, correct? So it'd be 16 minus 1, which is 15. Square root of 15. Come on now. I don't think that's too hard. Now, if you're going, oh my gosh, that's just way too over my head, then just go back and do 16 squared equals 4 squared plus x squared. And you can see how boring that is. All right? It's much quicker, much easier. All right? Now, here we go with question number 4. Use the Pythagorean triple to find x. So they're telling me that it's a triple. So what's common with 21 and 35? So this is 7 times 3. So this is 7 times 5. So this is 7 times 4, which is 28. That's how it should be done. That's why when people can tell you the answer, you're thinking they're doing 35 squared and 21 squared. It's not the case. All right? Anybody have any questions on what we're doing? I told you it's very easy. Now, it might require a little bit of practice on your part, but that's okay. Come on, what? Tell me, seriously. It's okay to say, I don't get it. That's perfectly fine. Nothing. All right, so do you want me to do 4 again, or do you want me to do 3 again? All right, so here we go. Watch me on 4. The first thing you do is you recognize that 21 and 35 have what in common? So here you go. So I put 7 down and 7 down. So now you're saying 7 times what? 7 times 3 and 7 times 5, right? So the answer down here is 7 times something. You agree with me? Now, what your next thing you're supposed to understand is that 3 and 5 are part of the triple. What triple goes with 3 and 5? No, don't. Listen, think for yourself. 4. So that's why this was a 4. And then we just did 7 times 4. All right, come on, don't stress out. Just learn to raise your hand and say, give me a little bit of help here. All right? Not a big deal at all. On any of those problems. Does anybody need me to slow down and go a little bit so you can see it better? I don't mind, really. All right, so that's how I'm expecting you to do it. All right, here we go. So here we have this boat down here, right? So I'm looking for x. So what's common with 45 and 60? 15. So this is going to be 15 times what? This is, so this would be, look at that. Bridget, is that good for you now? I'm going to let you talk just a second. All right, Bridget, I'm asking, so look up there and see. If not, we'll talk about it. Yes, ma'am. Yes. I multiply by 15. So again, here's what the important part is. Uh-oh. I recognize that this 5 right here, this 4 right here, and this 3 right here are the Pythagorean triples, correct? And then I just recognize that I multiplied each of them by what? Multiplied each of them by 15. Everybody good? Yeah. I told you, simple. All right, here we go. Now, it says, determine whether each set of numbers can be measures of the sides of a triangle. So the first thing you have to remember is a couple sections back, we had to first determine whether or not you could even make a triangle with these numbers. All right, in order to make a triangle with these numbers, we said the sum of the two smaller sides had to be greater than the third side. So, does 15 plus 36, is that greater than 39? So that's a yes. Over here, 16 and 18, that would be a what? Yes. Over here, 15 and 20, is that a yes? Yes. So one more time, for those of you guys who are not listening. Shh. Here we go. The sum, in order to have a triangle, the sum of the two smaller sides has to be greater than the third side. What?
It's asking for a cube of 2 sides.
I'm perfectly fine with that, trust me. I understand that completely. I'm trying to tell you. Part of the directions are determine whether each set of numbers can be the measures of the sides of a triangle. So the answer to number 6 so far is yes, yes, and yes. They all three can be triangles. So if I gave you 15, 36, and 39, could you make a triangle? Yes. All right. Now, if this was 15, 36, and 100, could you make a triangle? No matter how hard you try, you're not going to be able to make a triangle because the sum of the two smaller sides has to be greater than the third. All right. Now, what I want to do is I want to try to show you how simple this is. And most people forget it, but if you think about it, it makes perfectly good sense. How do you determine whether or not you can make a right triangle? Look right here. If it is a right triangle, a squared plus b squared will equal what? All right, now look. Come on, you gotta pay attention here because it's really simple. If I make C bigger, Ingalls, if I make C larger, what happens to the right angle? It gets bigger, so it becomes what? Obtuse. So that would mean that C squared is now what? Greater than A squared plus B squared. That is correct. So listen, very simple again. Let's go in slow motion. Right now, that's a right triangle. A squared plus B squared equals C squared. If I lengthen the hypotenuse, C gets bigger. Well, if C gets bigger, that means that C squared now is bigger than what? A squared plus B squared. Does that make sense? Right? So in your notes, you're supposed to write down C squared equals A squared plus B squared. It's a right triangle. C squared is greater than A squared plus B squared. It's automatically what?
Obtuse.
Obtuse. And then if you shrink C, it creates a what? A cube. So you would say C squared is less than A squared plus B squared. Now, this question was recently on the ACT test. So I always like to try to highlight special things. Geometry is becoming less in the SAT, becoming more on the ACT. So these are little facts, all right, that if you don't remember, you wouldn't be able to do the problem. All right, so one more time, it should make sense. If C squared is greater than A squared plus B squared, it is obtuse. And if C squared is less than A squared plus B squared, it is acute. And of course, if it's equal, it's a right triangle, which is what we've been saying for 3 years. What?
I thought that A plus B had to be bigger than C.
True.
To be a
triangle. So like, for example, 3, I'm showing you, I know what you're going to say. 3, 4, 5. That's a right triangle, right? 3 plus 4 is greater than 5. It is a triangle. And it's also right. Because 3 squared plus 4 squared equals 5 squared. See what I'm saying, right? It's not the individual letters. Also, I want to tell you this, guys. Some people in the past have said the square root of 3 squared plus 4 squared is not 3 plus 4. Do you understand what I'm saying? Come on, let's say it one more time because everybody makes a careless mistake. The square root of 3 squared plus 4 squared is not 3 plus 4. Everybody hearing me? Because you have to square and then add them. The square root of 3 squared plus 4 squared is 5. Do you understand what I'm saying? If I take the square root of the sum, I don't cancel. I have to do the addition before I do the square root. All right, like I said, every year somebody makes a careless mistake about that. All right, so now let's look at these real carefully. All right, now which one has to be C?
The biggest
Right, so you're just simply on your calculator doing 39 squared, and you're comparing that to 15 squared plus 36 squared. And it is a triple, thank you, because you could break that down dividing by 3, 5, 12, and 13. All right, thank you very much. So that is, in fact, a right triangle. That's a right triangle. So now, let's look up here real quick, because I kind of like that. So do you agree I could divide this by what? What could I divide that by? 2, right? So this would be 8, 9, and what? 13. 8, 9, and 13, right? So now we just have to compare 13 squared compared to 8 squared plus 9 squared. And 13 squared is 169, and 64 plus 81 is 145. So that's correct. So because it's greater than, we would say that is what? Obtuse. All right. Now the next one I could, is there anything common here? I don't think so, right? So let's go ahead and just compare 24 squared. We're comparing that to 15 squared plus 20 squared.
224 squared, I think, is 576. 225 plus 400. 576 is being compared to 625, less than, I believe it's cubed. All right, so that's really the only thing new for you, I think. That's the only thing new. Find x. All right, so again, I'll just do a couple more and then I'm going to let you go. All right, so what's common here? 4, right? There's common 4. So this is 4 times 3. This is 4 times 4. So my answer is 4 times 5, which is 20, guys. That's how I want you to do it. All right. Now number 10, this is what? 3 times 3, 3 times 5, 3 times 4. Look how simple that is. Right? Now actually, I want to help you with the fraction one. I want everybody to look up. Look at the fraction real quick. Let me show you how to do the fraction. This is just 1/5 times 1. This is just 1/5 times 3. So this is 1/5 square root of. See how, guys? Brilliant. 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 Come on, Alessandra, what? Why what? What's 1 squared? 3 squared. You with me now, right? 9, right? 1 plus 9 is 10. Square root 10. Come on, guys. And I understand. I don't want you. I want you to ask me. Did that register?
No, that makes sense.
Okay. Now again, you can see how I'm not doing 1/5 squared plus 3/5 squared, right? This is much easier. Just like on, look how simple number 12 is.
11.
Right? Wait a minute. Even better than 11.
33.
33. So let's go slow on this one just to make sure everybody's here. This is 33 times 1. This is 33 times 2. Now, that's the hypotenuse. So the other leg's going to have to be 33 times the square root of?
No.
3. Right? Now, those of you guys who are making a mistake, you have to remember it's the hypotenuse of the leg. If you're looking for a leg, you subtract. If you're looking for the hypotenuse, you do what? Add. Bridget, you good? Come on now. Come on. I know No, come on, girl. I'm trying to make you smarter. Look right here. Do you agree this is 33 times 2? And this is 33 times 1. So this answer has to be 33 times something. So all you're doing is you're just doing, come on now, listen to me. You're just doing the Pythagorean theorem with 1 and 2. So you would say 1 squared plus x squared equals 2 squared. You would be on that, right? All right, good, go.
Okay, so why for like the first, like the 2, 3?
I'm listening.
I don't know how to say it.
Okay, so let me do 2 again, real slow.
I understand. I just don't know.
Tell me, come on, kiddo.
On 2, there's 4 is similar.
Yeah, okay, so let me erase everything. I'm erasing right now. Hold on, give me a second. And then you can walk me through where you're just a little bit. Okay, I'm just going to erase to get out of the way. Okay, now 2 is all by itself. So what do you ask me now?
On 2, there's a similar 4.
Right.
And on 9 and 10, there is another similar number. But why are 9 and 10 whole numbers? Why do we make those whole numbers the 2 and 3 are left?
Okay, so let's look at 9. The reason they're whole numbers is because, watch, kiddo. This right here is a Pythagorean triple. 3, 4, 5. Shh. Walker, come on, man. I know. Right? Comedy's in your future, but not in my math class. All right? Shh. Hey, you hear me? Look up here. I want to show you something. This might help you. These up here are the numbers that always work out. If it's not one of those numbers, it's going to have a radical in it. You with me now, right? So down here, when we looked at question number 2, this was not a triple because this was 4 times 2, and this was 4 times 3, and 2 and 3 is not a triple. You understand now? All right, go, Cameron.
Can you go back to 13?
Yep, let's do 13 real quick.
Why did you? I don't fully understand why you multiplied by 1/5.
Okay, because I noticed in here there was a dividing by 5 and a dividing by 5. You understand that? I just pulled out, it's the same as the fraction 1/5. So do you agree that 1/5 times 1 is equal to 1/5, and 1/5 times 3 is equal to 3/5? So I put the 1/5 down here now because it was common here and here. And then I just did the Pythagorean theorem with 1 and 3. Okay, yes ma'am. All right, let's take a look at 14. So on number 14, I just recognized right off the bat. Come on, now this is a good one.
4/9 times 1.
Yes, 4/9. Thank you. Wow, 4/9. So right over here, I want you to look at this and say this just means 4/9 times 1, and this is the same as 4/9 times 2. So this is going to be 4/9 times whatever the result of the Pythagorean theorem is with 1 and 2, which is the square root of 3. That's what I'm hoping you can tell me. I'm listening if you have a question. Square them, and either you add them or you subtract them, depending on if you have the hypotenuse. Go ahead. That's everything is good. Everything is good. Don't worry. That's why you're asking. Okay, so now for number 15, let's just make sure. What's common here? 2, right? So this is 2 times 8. This is 2 times 15. So 8, 15, and 17. So this would be 2 times 17, which is 34. All right. Now again, some of you guys, if you just want to do a squared plus b squared equals c squared, I don't care. I just think you guys are smart enough to handle the triples. The end. Finish up. Now listen, homework guys. Just make sure you're doing 1 through 18, 21 through 29, and 38 through 40.
Whoa, repeat? Oh, I thought that was it. 21